We all know the textbook version of Saturn, the crown jewel of our solar system, defined by perfectly flat, serene rings and bright golden clouds. From a distance, the planet appears peaceful, but up close, it acts as a destructive gravity well that fractures moons and maintains an internal core twice as hot as the surface of the Sun. To study this environment, NASA, the ESA, and the Italian Space Agency spent years building the Cassini spacecraft, a massive, sophisticated probe designed to pierce the thick cloud layers. We are going to trace Cassini's actual flight path, starting from the outermost reach of Saturn's gravity and descending towards its high-pressure interior. To collect the final, rarest data on the planet's composition, the spacecraft would eventually have to sacrifice itself by plunging directly into the storms it was sent to observe. A moment of wonder. At the very edge of the system, a faint blue halo trails behind the moon Enceladus. This ring is formed by water vapor and ice fragments firing into space from massive geysers at the moon's south pole. Moving inward toward the main rings, we find a temporary cosmic graveyard. These structures are likely only 100 million years old and are already beginning to disappear. The rings formed when an ice moon crossed the Roche limit, fracturing into 17,000 trillion tons of ice. Rotational force pulverized and pushed these chunks into a thin disk 280,000 kilometers wide. Surviving fragments, called shepherd moons, carve distinct orbital gaps through this debris. These iconic rings are in a state of constant decay. Between the shepherd moons sweeping up material and the planet's gravity pulling debris into the atmosphere, the rings are slowly vanishing from the solar system. Dropping past the rings and into the atmosphere, the environment becomes increasingly violent. Wind speeds here reach 1,800 kilometers per hour, causing thick cloud bands to shear against each other in opposite directions. Over the North Pole, a stable, hexagon-shaped hurricane spans a distance wider than the entire Earth. This geometry is unique in our solar system. While researchers have attempted to replicate this shape in water tanks on Earth, creating a stable, six-sided vortex that lasts for decades remains impossible to simulate. This shape is dictated deep within the planet. Intense gravity squeezes atmospheric gas into a dense ocean of liquid hydrogen. This surrounds a solid core radiating at 11,000 degrees Celsius, shooting thermal heat upward to drive the massive geometric surface storms. The golden clouds visible from space are simply the outer layer of a high-pressure system circulating heat from the planet's interior. By 2017, the Cassini probe was running out of fuel. NASA had to choose between leaving the craft in a stable but inactive orbit or attempting a final high-risk dive to study the atmosphere up close. They chose the dive. In a series of orbits called the Grand Finale, operators maneuvered the probe between the inner rings and the upper cloud layers. On the 22nd orbit, the winds in the upper atmosphere finally overpowered the probe's thrusters. Cassini began spinning out of control, losing its direct line of communication with Earth. The spacecraft tumbled deep into the atmosphere, where it was eventually torn apart, crushed and melted by the planet's immense internal pressure. While Saturn's gravity eventually claimed both the probe and the moons that formed its rings, the data left behind suggests a system defined by constant transformation, moving between phases of violent destruction and complex new growth.